Hello everybody, welcome to your Topic 8 ticket to retake. I'm just going to go through each of these problems and do a little reteaching, reviewing, so please just use this video however it will help you best. All right, so number one, the graph of g of x equals ax squared opens downward. I'm going to underline that. And is wider than the graph of f of x equals x squared. So this is what we call our parent function. That's our f of x equals x squared. It's a parabola that opens up. It has a 1, 3, 5 graphing pattern. That's like the most basic parabola we can have. As soon as we start changing that x squared function right here, as soon as any other numbers appear with the x squared, then this starts to change. It could get wider, narrower, it could shift around, it could open down. And so what we have to come up with is a possible value for a. So a is our coefficient of x squared. Right now, in the original or the parent function, x squared has an a value of 1. So if we were to change that from a 1 to any other number, what number would make this parabola open down and be wider than the graph? So first I want to talk about wider. For our function to be wider, the a value is going to be between 0 and 1. Well, that is a sloppy way to write the word between. So basically, if your a value gets smaller, your graph will widen. And they say if your a value is between 0 and 1, it will be wider than this parent function right there. So any a value between 0 and 1. So I don't know, maybe a could be 1/3, or a could be 1/2, or a could be 0.2. We could use a decimal as well. So that takes care of it being wider. So all of these a values are wider than our parent function. And then for us to make this parabola open down, a values that are positive open up, a values that are negative open down. So I'm just going to make a note for it to open down. That means we need a negative a value. So all these possible a values I just wrote out, as long as we just throw a negative on each of these, so a negative 1/3, negative 1/2, negative 0.2, now all of these parabolas open down and they are wider than the parent function x squared. So all of those are just possible answers. There are a lot of possible correct answers, but those are just a few examples. All right, moving on to number 2. Which statement about the graphs of functions g of x equals negative 2x squared and f of x equals x squared are true? So we'll just go through each one. This could be a select all that apply, not necessarily a multiple choice. We just want to see if we agree with any of these. So is g of x wider than f of x? So for what we do when we compare to see if it's wider, we got to look at the a value. So for g of x, it has an a value of negative 2. F of x has an a value of 1. I'm going to ignore the negative. So I'm going to cover up the negative, and I'm going to compare the 2 with our g of x function with the 1 of the f of x function. So is a 2 wider or narrower than a 1 for an a value? So the bigger a number gets, the narrower a graph will get. The smaller the a value gets, the wider the graph will get. Since this 2 is bigger than this 1, that means that the graph is narrower, so it is not going to be wider. We're not going to select that one. All right, option B, the functions both open in the same direction. This a value is a negative 2x squared. This a value, maybe I'll write in a 1, is a positive x squared. A values that are positive open up, a values that are negative open down, and we have one of each, so they are not going to open in the same direction. All right, option C, they both have the same vertex. So our vertex of our parent function is, I just sketched out the parent function up above, I'll just use that, is at the origin. The only time that that changes is if we use addition or subtraction. If we add in numbers, that's going to shift your graph around left or right. So if I look at our g of x function, we have an a value, our x squared got multiplied by a number, but we didn't add in any numbers to make it any different than this one. So that means that this negative 2x squared has a vertex at the origin as well. So they will have the same vertex. So we're going to circle that one. And then do they have the same axis of symmetry? So our axis of symmetry is that vertical line. It's our symmetry line. It goes right through the middle of your parabola, so it goes right through the vertex. So if the two functions have the same vertex, then that vertical line will be in the same spot. So these two do have the same axis of symmetry. All right, number 3. What is the equation of a function that has a graph with a vertex that is translated 7 units horizontally to the right? So I'm going to make some notes. We want to go to the right 7. 7 units horizontally to the right of the vertex of the graph g of x equals x plus 3 squared plus 4. Okay, so we want to be 7 units to the right of this. So we have to, let's see, write an equation of a function. So we're going to write a new function that is 7 units to the right of this. So this is vertex form. Vertex form shows us how our vertex has shifted, and we can see kind of without doing any work where the new vertex will be. Now we all know that this x plus 3, tricky x, this means that this vertex would go to the left 3 units. That plus 4 on the end is going to move our vertex up 4. So the vertex for this function, if I go to the left 3 and up 4 from the origin, is at a negative 3, 4. So that's where the vertex is for g of x. Now we need to write our own function that is 7 units to the right of this. So if we think about visually what they're saying here is, let's see, we're at negative 3, 1, 2, 3, 4. Here's where this function is. It has a positive a value, so it's opening up like this. We're going to take this vertex and move it 7 units to the right. So if we go 7 units to the right, I know we're going to go 1, 2, 3 and hit the y-axis. And so we have to go 1, 2, 3, 4 more. And that's where the new vertex will be. So maybe we'll call this one, I don't know, h of x equals, the a value we're not changing. Our new vertex right here is the point 4, 3. So because the vertex from the origin is to the right 4 and up 3, we're going to say x minus 4 for that tricky x. Don't forget the square, that's what makes it a quadratic. And then plus 3 for that vertical shift. So this function is 7 units to the right of the function of our g of x function. So for that problem, we had to figure out where is the existing vertex, and then from there we move it 7 units to the right, and then what is the function for any quadratic with that vertex. All right, next problem. The graph of h of x is a translation 3 units to the right and 4 units down of the graph of f of x equals x squared. Write the function h of x in vertex form. All right, so again, I like to take my notes. Let's see, it said to the right 3 units and then down 4 units. And we are just going from our parent function x squared, which has the vertex at the origin. So h of x, our new function, is going to be equal to, they didn't say to make it wider or narrower, so the a value will stay the same. So the a value, I could write it in right here if I wanted to. It would be a 1, but you don't have to write it in. That's optional right there. Now, if we're going to the right 3, that means we have to say minus 3 for tricky x squared. And then down 4 is minus 4 from the origin. So there's our h of x function. Tricky x, this would go to the right 3, down 4, and that's what we said. Don't forget our little squared. That's an easy piece to forget, but that is what makes this a quadratic, a parabola shape. If we didn't have that squared, this would just be a linear function, so we want to look out for that. All right, number 5. The function h of t equals negative 16 t squared plus 96t models the height in feet of an object thrown in the air. What is the object's maximum height? So let's go ahead and circle maximum height. Anytime that you need to find a maximum height of anything, you need to find the vertex. Now the vertex is an ordered pair. It has an x and a y value. So we're going to go ahead and find the vertex, but then I want to talk about what part of the vertex actually answers this question. This is standard form. We have our ax squared. They changed the variable to t because this is a vertical motion model where t is your time, but there's your x squared. Plus here's our bx, and then we're missing that c value on the end. It would be plus 0 if we wanted to write it in. But this is standard form. We find our vertex from standard form using our little formula x equals negative b over 2a. So our b value is, you already up here, there's b, here's a. So negative 96 over 2 times our a is negative 16. So that's a negative 96 over negative 32, which is a positive 3. So we have to find the vertex. We just found that the x value is 3. Now to get the y value, we just have to plug that in for our variable. I guess our t's, but you know, t's, x's, same idea. So we're going to do negative 16 times 3 squared plus 96 times 3 and see what we get. So when we calculate that, we get 144. That is the y-coordinate of your vertex. So if we think about what that means in a parabola, the vertex is at the ordered pair 3, 144. So if I go over 3 and up 144, that's where the vertex will be. And then this is a quadratic equation that has a negative a value, so it is going to open down. So that's what we're looking at. So what is the maximum height? Now the x value of the vertex, the first part you find, it just tells us how far over we go on our x-axis, but it's the y-coordinate that tells us how far up we're going to go with something. So the maximum height is the y-coordinate of your vertex. So to answer the question, what is the object's maximum height? It is 144 feet. All right, last question for the front page. We have to graph this function and we're going to find some key information, some key features in order to do that. What we want to recognize is that this is vertex form. A giveaway for vertex form is the parentheses right here. When you don't have those parentheses, that means everything has been multiplied out and you're looking at standard form. Vertex form is a great form. It's a great form if you have to graph because we can identify the vertex right away. So our vertex, here's where we're shifting horizontally, x minus 2, so tricky x, that's going to turn into a positive 2. And then on the end, that's our vertical shifting up 4, so we're going to go to the right 2 and up 4, so there is our vertex. Now axis of symmetry, here, maybe we'll draw in that vertex. All right, so our vertex is at 2, 4. The axis of symmetry is the vertical line that goes through your vertex. And that line is at x equals 2. So you may already remember that your axis of symmetry is always going to be the x value of your vertex. Those are always the same number because this is the vertical line that goes through this point, and our vertical lines are always x equals 2, so it's going to be the same as that. One thing with axis of symmetry If you don't have this x equals, if you just write the 2, you're going to lose some credit on that because this is an official equation of a vertical line. So you have to have the x equals. If we just have the 2, we're going to think maybe you're talking about a point, or it just gets a little confusing. So equations of lines have to have the x equals, or vertical lines. All right, now the y-intercept. In vertex form, we've got our a value, -3, right here. We've got our horizontal shifting and our vertical shifting. None of these numbers are the y-intercept. So we don't know the y-intercept when we look at vertex form. So if you're asked to find the y-intercept, here's where you have to do a little bit of work. Now, you can find a y-intercept of any function. It does not matter if it's a quadratic function, a parabola, a linear function, straight line, all the other functions you're going to learn in your mathematics education. All you have to do to find a y-intercept is plug in a 0 for x. So I'm just going to take the function -3 times 0 minus 2 squared plus 4. And then I'm just going to calculate that out. So y-intercepts can always be found by plugging in a 0 for any x's in the function. And the y-intercept is -8. So that's going to be the ordered pair 0, -8. All right, so last question is show work or explain how to find more points on the parabola. So the way that I taught you guys how to do this is that 1, 3, 5 graphing pattern. I mentioned it up above, 1, 3, 5. But that's the graphing pattern for the parent function if it's just an x squared. As soon as your a value changes, our graphing pattern changes because it will change the shape of your graph. It will change if it's opening up or down, all that good stuff. So we have to find our a value. A value is this -3. So what we do is we take that -3 and we multiply it by the 1, the 3, and the 5. So our new graphing pattern becomes, it's a -3, -9, -15 pattern. All right, if it helps, you can put those over 1. Now what we're going to do to graph from here is from the vertex, we're going to do that -3 over 1. So we go down 3, 1, 2, 3, to the right 1. And that's going to be the first point that we plot. All right, next we're going to go down 9 to the right 1. So if we go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, to the right 1, oh good, that fits. So there is the next point on our parabola. That's the right side of the parabola, so we do want to go ahead and get the same points on the left side. So down 3 to the left 1, down 9 to the left 1. Parabolas are symmetrical, and I'm going to talk here in a second about some things we can check. So are we feeling pretty confident about how we graph that? So we have a couple of things that we can check on. First of all, our a value is negative, which means the parabola is opening down. What we graphed is opening down, so that's good. Let's see, our a value, if we ignore the negative, is a 3, which gives us a narrower graph than the parent function. So this graph did get narrower, so that's good also. And then another good checkpoint is the y-intercept. So mathematically, we know that this function will cross through the y-axis at -8. And then when we did when we graphed over here, we can see that here's a -5, 6, 7, 8. It is crossing through the y-axis at -8. So I feel pretty confident that this is the correct graph for that function.